a new series where we will discuss the LLM application and the agent observability with LangSmith, right? So this LangSmith is part of the LangChain ecosystem, which mainly deals with the LLM application or the agent observability, where we not only we can observe these applications, but we can also evaluate these applications if we are doing continuous development. So with nowadays, like most of the LLM applications are getting matured and they are getting deployed into the production, and this type of monitoring and the observability part is getting very crucial if you are deploying your applications to the production, right? So without further delay, let's get started. Okay, so let's first discuss what this observability is, right? So LLM observability is the process of collecting real-time data from this LLM models or the LLM applications to understand their behavior, performance, and the output characteristics, right? So this three part is quite crucial. Like if you are building a LLM application, to understand their behavior and the performance, how the model or the application is performing, and also if there is any issues that are present in the output characteristics that we can monitor, and that there we can find out those root causes, and this will help us to track those issues, right? So with this, let's first understand why we need LLM observability, right? This is mainly to deal with the nature of LLM, right? Which is or the LLM applications where we have a lot of complexity, and also these applications are non-deterministic in nature, right? So you might have seen while you are building your LLM application that if you are sending a single prompt or a single input to your LLM application or your GenAI application, you are getting different results at different iterations, right? This is due to the nature of the LLM, which is very non-deterministic in nature, or the probabilistic nature of the LLM model, right? And the observability piece, which we will cover in this series, will help you to understand this unpredictable behaviors, and also help you to remove some part of this non-deterministic nature of your LLM applications, right? So then there is a concept of performance optimization, where using this LLM observability framework, you can track the latency, the throughput, the token usage, which can not only can optimize the cost, and but you can also make your systems much more efficient, right? By reducing the latency, or you can make the user experience much more better with these techniques, right? So then there is a concept of debugging and troubleshooting. Like if you are building a very complex looking LLM application or GenAI application, then pinpointing the root cause of this LLM application can be challenging, right? Where manually you need to put a lot of logging, and you need to figure it out where actually the things are going wrong. But if you apply this LLM observability framework, those monitoring and tracking would be much more easier with this frameworks like LangSmith. Few other applications are also there like LangFuse, so we'll see if we can cover those in this series, right? So then we have this cost management. So as I already mentioned, like this LLM applications cost can be monitored with the help of this token usage, and also the resource consumption, right? Which directly has impact in terms of your operational cost, right? So with the help of these things, we will see how we can track the token usage or the tokenomics, and then we can also monitor the resource consumption with the help of LangSmith, right? So which can make your systems much more cost optimized, right? So then we have the most important part, where you can have inbuilt mechanism of performance evaluation, where you can have a standard data set which you keep on doing evaluation on top of that data set whenever you are making any changes at your application level, right? So if you have deployed a version v1, then you made some changes either related to the retrieval process or to your system prompts, then you create a new version which is v2, right? But how the v2 is better than the v1, that you can track by doing the performance evaluation with the help of a data set, right? So which we'll see in the future videos how we can do that, right? So which will help you to improve your strategies of deploying, and will help you to get into a right path of deploying your LLM applications, right? So then a few things you should be aware of. So some of the concepts which are related to observability are like trace and span. So this trace is what we can call it as, like if you are sending a user input to your LLM application, then this whole user interactions, right, or a single request which goes to an LLM from input to output, that is what we call as trace, right? So the complete user interactions that starts from the user firing a prompt or a question to your LLM application, then till generating the response, it is a full trace, right? So in between there might be a lot of steps which are like retrieving the document, then doing a tool call, then generating a response with the help of like either the response from tool call or the retrieved documents. So those are part of this full trace, right? So trace is like a one of the parent you can think of. Then in between this trace we can have a lot of several steps, right? So for this example we can see like this rack process, we can treat it as the application which we are building that can have a lot of in between runs, right, which are like, which we also call as spans, like retrieve documents, then it can have a step called re-ranking, then finally it generates the answer with what we call as generation process, right? So this each of these steps we can treat it as a span, right? So span is a single measurable operation within a trace representing a specific step or a task in the process, right? So here the re-ranking is a span, right? Here the generation process of the final response is a span, right? So your trace is a collection of spans, and this span typically represents a single end-to-end operation in an LLM application, right? So now there is another concept which is related to this LangSmith ecosystem, where we kind of group your trace and spans to a single project, right? So if you are building a RAG application, then you can name that process or that project with a specific name. Then all the traces which you run and all the spans that are part of the trace will be grouped together under this project, right? So with this, let's get our hands dirty with the help of LangSmith. So we'll start with very basic. So this is one of the application which I have built and which I'm trying to do the observability implementation with the help of LangSmith. So first of all, like we will load the environment variables. So if I just show you the demo.env file where we have few of the important parameters which you need to bring in, like which are like LangSmith API key and the LangSmith project, right? So this we have to mention in this .env file. You can also mention in your notebook itself, but for the safety and the privacy, we typically move this keys to the .env file, right? Now the question is how we can get this LangSmith API key, right? So what you can do is you can go to this smith.langchain.com. So there you can create your account, and once you create that, you can go to the home section. There you can get this option like setup tracing, right? So once you get this option, you can click on this generate API key option, and there you can generate your own key, and that you can put into your .env file or part of your notebook file itself, right? So once you do that, then you can start using it, right? So what you can do is at first you can initialize, you can get those keys from the .env file, and you can set those as os.environment or the environment variable. So LangSmith API key is one of them. Then you can give a project where the traces will be grouped under this project. So we are naming it as LLM OBS YT. So then we also need to mention this parameter or this environment variable, and we need to set this value as true, right? So the name of this is LangSmith underscore tracing, right? So this is not a Boolean value, so this is a string which you need to set, right? So once you do this, you can run this steps, and after that, what we will do is we will not use the LangChain as a framework here. So we will use the standalone OpenAI client, and based on that we will try to see the LangSmith features, right? So at first in this video, I will show you how you can integrate LangSmith into the OpenAI standalone API call. And in the future videos, we will go into the more depth and we will see how easily you can track LangSmith whenever you are using LangChain or LangGraph as your supporting environment. After that, what you can do is you can create your RAG vector DB, right? So what we are doing here is we got a sample PDF, which is a paper. I have taken like first few pages of this paper and I kind of created a .pdf file. And after that, what we will do is we will kind of get that PDF, we will chunk those PDFs and we will push that PDF or the chunk of that PDFs to the vector DB, right? So once you have done that, then you can start creating your application, right? So while creating the application, you can start integrating the observability part, right? So where we will trace with the help of LangSmith, right? So this is we will see like how you can use LangSmith whenever you are not using LangChain or LangGraph, right? So this will give you the very in-depth understanding how typically the LangSmith is working. So what we do is we kind of use this traceable decorator, and there we can mention several run types, right? So we can see like there are several run types which are part of LangSmith. So LLM is one of the run type where it whenever you are doing a LLM call, you can mention this as runtime while you are initializing this decorator. Then we have the retriever, right? So where whenever you are retrieving certain documents, you can mention the runtime as retriever. So then we can use it for tool call. So there is also a default option which is chain. So whenever you don't mention anything, so it will be treated as a chain which can combine several steps into a larger process, right? So then we have like prompt and also the parser, right? So first of all, what we are creating here is we are creating a function which is retrieve documents. So there we are passing the question and we are doing a vector DB retrieval, right? And you can see we are mentioning it with the decorator of with the help of LangSmith. So I have imported this decorator previously. Here you can see like from LangSmith I have imported the traceable the decorator, and after that you can mention here, right? And you can mention this run type as chain, right? So then we have this generate response function where we typically do is we get this the output from this retrieve documents, then we kind of loop through the documents, we get the page content and we create a formatted docs, right? And then as we are using a simple OpenAI API call, so we are creating a message, kind of use this message which we will pass to the OpenAI API call where we give a system prompt which is this one. Then we also give the input from the user where we pass the context as the formatted docs and the question which we get as an input to this function, right? So then we make the LLM call here itself and we return back the response, right? So we have a function which is LLM which we are implementing here. So you can see this we are also decorating with traceable and we are mentioning the run type as LLM, right? So we are getting the input as messages, which is nothing but list of dict, and then we do a OpenAI API call where we mention the model name, then the message and the temperature, right? And we send the response from this function, right? And everything we kind of integrate using this function which is rack chain. So there we pass the question goes through the retrieve documents where it will fetch the formatted documents. Then we call this generate response method where we pass the question and also the formatted docs, which will in turn it will do the LLM call and it will generate the response, right? And so then we are just only sending the content which is part of the OpenAI response as a return from this function, which we will treat it as the response, right? So let me first run all these things. So once we run all these things, then we can start firing questions, right? So the question which I'm asking here is tell me about multi-head attention in transformers, right? So you can see the response has been generated. Now let's go to the LangSmith platform and see how it has been tracked, right? So what we need to do is we need to go to this tracing projects. So our project name was this one, which is LLM OBS White. So you can see this is the latest one which I ran. So you can see this executed successfully, and this is nothing but a trace, right? So we have this project which is LLM OBS YT, and each of these instances are nothing but a trace, and each of these traces will have the corresponding span, right? So you can see like this is the trace. We will have our ID. So this ID is nothing but, we'll see this is a trace ID, and inside each of this trace we will have the spans, right, or the run, right? So in LangSmith they call it run, but like few other framework they also call it as span, right? And you can see it has several steps, like retrieve document is one of the step, and you can see each of this as we mentioned the run type, it is also showing you this is a chain, and this is a retriever step where it goes to the vector DB and then it pulls the document. Then we also have a chain which will generate the response, and the last one is a LLM call, right, where the run type we mentioned as LLM, right? So let's first go to this. Like we can see at the top level we fired the question and it generated the output, right? So in the side we can see like it shows you the start time, the end time, then whether it got succeeded or not, and also the number of token it has consumed, right? So you can see it has given you the details, like the prompt consumed around 1735 tokens and the completion took around 168 tokens, right? So you can see like at each level we can track the individual token usage, right? So then we can go to the individual runs or the spans. So if I just go to the retrieve documents, there we can see like the question is mentioned, then the document that has been retrieved, right? So that we can also see here, right, which gives you the detail. And not only that, it gives you the other details also, right, like which page number has been used, what is the source document name, then what is the creation, and few other details which can be very helpful if you are trying to debug this RAG application, right? So then it also shows you the vector store retriever step, and as it is a vector store retriever step, then there is no token cost associated it, but it gives you the latency, right? So which can be a issue, like if you are building a RAG application, if your retriever step is taking a lot of time, then you want to optimize that, right? So this step will give you an idea like what is the a retriever step, like what was the latency associated with that, right? So then we have the generate response phase where we show the full thing, right, where we get the question, then the document that has been passed, and the output details, right? And it gives you a lot of details which can be very useful, right? So you can see like the prompt token or the total token that has been used. Then if you go to the LLM, and then it also gives you the details, right? So it tells you like this was the system message or the system prompt that we have passed to this LLM call. Then this was the human message, right, or the role where the role was equals to user, right? So you can straight away identify which are your system prompt and which was the user input, and then in the end it will also generate a response, right, which is nothing but the AI response, which is the LLM response, right? And you can individually track like the latency that is associated with this whole step, and also the in between step output, right? So this is quite useful if you want to track your application in terms of the latency and what are the documents that has been fetched from the RAG, and how finally the answer got generated, right? So this is all I wanted to cover in this first video. So slowly we will go into the in-depth coverage of LangSmith and how you can leverage LangSmith to track not only your LLM application, but we will also see how we can use it for the agent observability, right? So with this I will end this video. Thank you for your time. See you in the next video.